Hi all, welcome to part 16 module 2 logic system design. So if you are in the track, last video we discussed about the K-map. So we are continuing our discussion on K-maps. If somebody is directly coming to this video, please watch part 14 and 15 and come to this so that it will be clear for you. Okay. So that's all. So right here we will see the K-map for the 4 variables. So far we saw the K-map for 2 variable and 3 variable. Now we are going to see the one for 4 variable. And as you know, 4 variable, how many minterms are possible using 4 variable? Using 4 variable, I can have a 2 raised to 4, that is 16 minterm, right? Minterms. So that is my minterm 0 to minterm 15. So I have to represent all of them. So the same truth table I am representing in a different way. That's also I need entry for all the 16 minterm. So how to give an entry for them? So what I am doing is, so I have a 4 variable expression. So let the variables be f. So I have a function expression Boolean function something like f having variables x, w, x, y, z. So 4 variables are there, right? So what I am doing is I have a 16 cells, so I can arrange them conveniently by a structure like this. So here you can see that 4 rows and 4 columns, together there are 16 cells. So this 16 cell, the row number corresponds to the first 2 variable. You can give the naming in any order. So here we follow the normal sequence order. In different way also you can represent, but the only thing is you have to capture the minterm correctly, that's all. So this is the one explained in the textbook, that is what we are seeing. So that wx, so, and the variable wx, 2 variable only I am considering at a time, can have 4 choices like 0, 0, 0, 1, 1, 0, 1, 1. But see, you have to use the grey code, keep that in mind. So 0, 0 will come and you know the reason, everything. 0, 0, 0, 1, then 1, 0 should be written here, then 1, 1, like that. Either you can remember like that, or actually you are writing the grey code. Okay. Similarly, for the variable y is that we have 0, 0, 0, 0, 0, 1, then 1, 0. So just remember this. So what we are writing here is the grey code. No, it's not the normal binary in sequence. Okay, and accordingly, because adjacent numbers we want to differ in only one bit, so that you can group, when you group them, one variable is getting eliminated. So that is the entire logic behind this. Okay, so that is very important. Now you can accordingly see the labeling. So you can see that this is something w, x, y is how to read this particular cell. This cell corresponds to 0, 0, 0, 0, 0, 0. So all 0, that is M0. Okay. Similarly, this cell corresponds to 0, 0 for row and 0, 1. So altogether this cell is actually 0, 0, 0, 1. 0, 0, 0, 1 is 1. And here you can see that this corresponds to 0, 0, 1, 1. 0, 0, 1, 1, it is the binary of 3. And here this corresponds to 0, 0, 1, 0, like that. That is 2. Okay, so hope it is clear. And let me tell you a quick way of doing this. So one way you can just go through the labeling of the row and column, you can write it, but in the exam you don't have to consume that much time. So just follow the way I am following. So what I am doing is I am filling like this. One second. Let's continue. So what we see is like so see how to do this numbering easily. So you can go like this. If you remember this order, you can do it very fast, that's all. But keep in mind, this is with respect to this kind of a labeling, this w, x, y, z. The first 2 variable I am taken for the row, and second 2 variable I am taken for the column, and accordingly I am giving the grey code like this. So you can see that see 0, 1, 2, 3. So first till half you go like 0, 1, then from the other end you come, so 2, 3, like that. Then 4, 5, 6, 7. Okay, so now the first half is over, just go to the last one. So that is the order we are following. The first we will go till the half, then from the other side we will come, right? Then 4, 5, from the other side we will come 6, 7. Now again row wise the first half is over, so you have to go to this 7, then 8 will continue here, then 8, 9, again go other end, 10, 11, then 12, 13, again go other end, 14, 15. So hope you get the way how I am filling the number easily. But you don't have to remember this, no way, no problem. Simply this understanding is enough how to fill the number using the labeling of the row and column, that's all. But it may save your time, that's why I explain like this. Okay, fine. So that is how, and you can see, so here everything is explained here clearly. You can see that this corresponds to 0, 0, 0, 0, and 0, 0, 0 is nothing but w dash, x dash, y dash, z dash. That is a minterm. that minterm in the truth table will look like w, x, y, z all are equal to 0, something like that. So this corresponds to 0, 0, 0, 0 and 0, 1, right, 0, 1. So the minterm will be w dash, x dash, y dash, but z is as it is, z, because z is 1. So like that, okay. So that's all. Okay, fine. Let's see this question. Simplify the Boolean expression. I have a 4 variable expression and its sum of product expression is given. I may be doing it in a very easy way. Okay, so what we are going to see is, okay, I just want to remember the numbering like 0, 1, 2, 3, 4, 5, 6. Then 7 is missing, 8, 9, 10 is missing, 11 is missing. Okay, we will see 12, 13, 14. Yeah, let me take a new page. So I explained in the subsequent video, but if I am doing from scratch, it will be easy for you to follow, right? So that is why. So the expression given is like a f is f of abcd or xyz. Anyways, it is something like a sigma of 0, 1, 2, 3, 4. Sigma of wxyz 0, 1, 2, 3, 4, 5, 6, 8, 9. 5, 6, 7 is missing, right, 8, 9. This was like a w, x, y, z. 4, 5, 6, 7 is missing, 8, 9, 10 and 11 missing, 13, 10, 11, 12, 13, 14. 12, 13, 14. So it's a very bigger expression. So definitely we are going to simplify it to a very nice expression. We will see that. So we have to draw the table, right? So how to draw the table? There will be 16 cells. So there will be 1, 2, 3, 4, 4 columns and 4 rows, right? And the row number corresponds to wx and here it corresponds to yz, and labeling is like a 0, 0, 0, 1, 1, 0, 1, 1, gray code, remember that, okay, 0, 0, 0, 1, 1, 0, 1, 1. Now I am not looking at the labeling, directly I am writing the minterm here, maybe. So I am not writing m also. So what I mean is a minterm. Okay, so this is the minterm 0, minterm 1, minterm 2, then 3, 4, 5, 6, 7. So come here 8, 9, 10, 11, then 12, 13, 14, 15. So hope you understood the way I am writing the numbering. Then simply fill the table with the entries. So what are all the entries I am having? So I have a 0, minterm 0 is 1, minterm 1 is 1. So I am just looking at this label and I am filling. And 2 is 1, 3 is 1, 4 is 1, 5 is 1, 6 also 1, 7 is not 1. Then 8, 9 they are 1, then 12 is 1, 13 is 1, 14 is 1. So this many terms I got. Now I want to find out the largest grouping of ones. So what I can do is, so here you can see that there are, see, it's a very nice grouping, right? So once you get this grouping, that's all. So if you miss the largest group and if you are wrongly making the group, you may get the wrong answer. So always go this structure. I mean some kind of rectangular shape you will get, and with the largest number of ones. So this is the largest group possible. 8 ones are grouped. So definitely how many variables are going to be eliminated? So that is my question. So see, how many ones I grouped? I grouped 8 ones. 8 ones I grouped, or 8 minterms I grouped. Accordingly you can see that in the final simplified expression, what is 8? 8 is actually 2 raised to 3, right? So 3 variables will be eliminated. 3 variables eliminated in the final simplified expression corresponding to this groupings. That is the power of largest group. When you make a group of some 2 power n cells, you can see that n variables you can eliminate, something like that, right? And you know the original function is having 4 variables. So the the corresponding group, the group corresponds to one variable term. So finally you will get the entire group simplified, the group simplified something like this, group simplified to one variable term, something like that. What is that term? So let's see. So when you move across the rows, look at the row labeling, you can see that if there is a change from 0 to 1 for any variable, you can eliminate that variable. So that is what we seen, right? Same thing apply here. So you can see that when you, if that, can you eliminate the variable w, because when you are moving across, you can see that the variable w is changing from 0 to 1. See, actually what is happening, if you write the min term for this, this is something like this corresponds to w dash x and this corresponds to wx, right? So when you add these two things, you will get it like a, you can take this x outside, this is something like a w plus w dash plus w into x, you can take as common, and this is 1 and this will be x. So actually you are eliminating w. So that I am saying in a different way. So when you go across the row labeling, at any point the variable is changing from 0 to 1 or 1 to 0, that variable you eliminate, because on the background that variable and its complement are added, right? That is nothing but 1, that you can ignore, that's all. Similarly, you can see that when you are moving from here to here, you can see that this variable x is changing from 0 to 1. So with that eliminate x. Okay, so I am not writing that much detail, hope it is clear. So same thing applies. So both the w and x are eliminated, and what else? So now if you look at the same grouping, when you are moving from column labeling, moving across the column labeling, you can see that the variable y is retained as 0, no change. So you can't eliminate y, but the z is again eliminated because z is changing from 0 to 1. So eliminate w, x and z, and what remains for the entire expression? This entire expression corresponds to just the term, that is y, and as it is 0, the term is nothing but y dash, that's all. Now tell me what is the next grouping possible. So if any doubt, we will see more and more example, it will be clear. Now see, these two ones are there, right? So I mean these 4 ones are there. I am trying to make the largest group. See, these two one, this is the same the thing that will come, that most of you may be thinking, like these two ones I can group, that is the largest grouping possible, but is it correct, right? You can have overlapping, no problem, but the only thing is at least one single one should be there in the group extra. I mean, if you are writing some overlapped one, but a smaller subset of this, that is meaningless. These two ones you want to make the largest group, and that time you can depend on these two ones also, there is no problem. Don't think that overlapping is going to create some issue. It's not going to create any issue. In the previous examples also we saw like that, right? So we are going to group the largest, we are trying to get the largest group by grouping 4 ones. So if you are grouping 2 ones, further there is a chance of simplification, so keep that in mind. So always try to have the largest one, overlapping is fine, but finally at least one min term should be covered extra, otherwise that the group itself is a redundant one, that we don't want redundant grouping, but we need something, but more technicalities are there, we will see that. As of now, hope it is clear that 2 ones I am trying to make the largest grouping possible, that is this. Again 2 ones are left, but we will see that. So before that, what is this group corresponds to? This 4 1 group corresponds to, you can see that as I grouped 4 ones, 2 variables are eliminated, and which are they? You can see when you are moving across the rows, you can see that the variable y is changing from 0 to 1 at some point is enough, and the variable z is also changing from 0 to 1. So those 2 variables are eliminated, and when you look at the row, see these 2 variables, they are not changing, right? The w is maintained to be fixed, that is 0, so w dash and x dash. So this whole group corresponds to w dash x dash. So that is the next term in the final simplified expression. And let me tell you, so now it is very important, these 2 ones, how we are going to group it. Again, the simplest thing that most of you will be thinking is I can group like that, but don't do like that, because just try to see is there any chance of having a bigger grouping other than these 2 ones. Bigger grouping means next it will be 4 ones, right? So can I have a group of 4 ones? Is it possible? It's possible. because this is something I explained to you in the previous video also. You can try to visualize it like this table is folded. So when you fold this table, you can see that these two ones and these two ones are coming nearby. See, I am just eliminating this part from the final one. So hope you understood this, right? This logic, why that variable is eliminated. That is what I was explaining here. Let me remove that. Okay, and let's continue with our so what I was trying to say is, what I can do is I can have a bigger grouping like this. So keep that in mind. So now the group is containing these two ones and these two ones, so something like this one, this one, this one, this one. All these four one together I made a single group. That is the thing. How I was able to have such a grouping, because when you fold this table, these four ones are coming together nearby like that. Okay, so that is also applicable. Keep that in mind. So you can fold this table also, but you can't visualize it. So how many ones are coming nearby, that also we will group. That is the idea. So same thing I explained in the previous video also. So now tell me what is the corresponding term. So this biggest grouping corresponds to what? So this whole thing corresponds to what? So this four ones corresponds to what? When you go across the rows, you can see that just before that variable w is changing from 0 to 1, or that variable is eliminated. So what remains is x. X is in the pure form, it is 1. So x will be there. Now you have to travel from this first column to last column, because first and last column are now nearby. That is what you grouped. So when you move from first column to last column, you can see that the variable y is changing from 0 to 1. That means that y is eliminated, but z is, see, fixed 0 0. So that means z will come in the final expression as z dash. 1 is eliminated. So this corresponds to x z dash. So that's all. So how many terms are there? Any one is missing? No one, right? So all the ones I grouped, and I tried to make the largest grouping possible. So the thing f of a, b, c, sorry, it's a 4 variable expression. F of w, x, y, z. It's given like a very bigger expression, but I minimized it to a very smaller expression. Say the first term I got was y dash, then w dash x dash, or let me write it in the order x dash w dash, okay, plus x z dash, something like that. I just have 5 literals only, 5 literals. I got a very small expression with 5 literals, that's all. So hope it is clear. So sometimes they can give you the question in the canonical representation, this sum of product, sum of min term, sigma expression, or sometimes it may be given in a form like this, and you know from this representation how to make the other one. So you can go like that. So what you can do is, this is nothing but equivalent to that a dash b dash c, so which is missing the variable. So this is a 4 variable expression, so I think it is f of a, b, c, d, and you can see that d is missing. So a dash b dash c dash into d plus d dash, you multiply like this, and here a is missing. So a plus a dash into b dash c d dash, right? So wherever it is missing, and there you multiply by 1, and that 1 is nothing but a plus a dash of b d plus d dash. So hope it is clear. So we have done it many times. Now this is exact min term. No, you don't have to do anything d dash, right, with this. Now tell me what is this? A b c, a b dash c dash, d is missing, d plus d dash, like that I multiplied. Now expand all the terms. So this is nothing but a dash b dash c dash into d plus a dash b dash c dash into d dash, right? Now plus a b dash c d dash plus a dash b dash c d dash, right? Plus a dash b c d dash as it is, and the last one a b dash c dash d, a b dash c dash d dash, like that. Some of the terms may be repeating or may not, we will see that. Now this corresponds to what? This is nothing but 0 0, let me write it if you have any doubt. 0 0 1, okay, that is 1. So this one is 1, or that 1 is enough, right? Now you know binary and decimal is very clear to you. So this is 1, this is 0 0 0 0, all are 0 0, this is 1. So write like this, 1 0 1 0. So 1 0 1 0 is what? 1 0 1 0 is 10. Hope you remember. Okay, now it is 0 0 1 0, that is 2. 0 0 1 0. and this is what, a dash b c d, sorry, 0 1 1 0, 0 1 1 0 is 6. Now this is what, 1 0 0 1, that is 9, right? I may be making mistake because even I am only communicating, right? So if I am making any mistake, you know the method, right? Accordingly you can correct yourself and you can proceed. Maximum I will not try to make any mistake. So this is like a 1 0 0, what is the last one? It is d dash, so that is also 0. So this is like 8. So here nothing is repeating, so nice, right? So 1 0 0 0 8, here it is 9. I am re-verifying. 0 6, okay, fine. 0 0 1 0 2, 1 0 1 0 10, all are 0, 1, fine. So this is nothing but I am writing them in order. 0 will come first, then 1 will come, then 2 is there, then 6 8 9 10. Is it correct? 1 0 2 6, I added all the terms, right? Fine. So this is a done. Now once you get in this form, you know it, right? How to have the table and come up with the answer. The solution is given in the subsequent slides, or let's see this also. So 0 1 2, then 6 8, like that it is going. Okay, let's take the next page. So what was the expression we got? F of a b c d we obtained like sigma 0 1 2, then it was 6 8, like that, right? 0 1 2 6 8 9 10, 6 8 9 10. So that is the one, and you just draw the table. Table drawing is something difficult for me because I can't give the proper structure. Okay, let me try. Okay. Oh, God. So 4 columns, 1 2 3 and 4, 4 rows, 1 2 3 and 4. So this corresponds to first two variable, and then 0 0 0 1 1 0 1 1. See how fast we can do it. 0 0 0 1 1 0 1 1. It's a very easy technique, but you just know you have to practice more, that's all. 0 1 2 3 4 5 6 7, then go last, right? 8 9 10 11 12 13 14 15. Now just keep filling the table with this entries. So what are all the entries we are having? Okay, 0 is present, 1 is present, 2 is present, okay, 6 is present. Let's use a different one. 0 is present, 1 is present, 2 is present, then 6 is present, 8 is present, okay, 9 is present, 10 also present. So this is the kind of numbering we are having. Now let's start grouping. So tell me which is the largest group possible. See, one group possible is, I am confused on the color. Okay. See these two ones, and as I already told you, see, always make the largest group. Do whatever things you want. If you want, you can fold and you can try to see whether a grouping is possible. So when you fold them together, so that those 4 ones will come nearby, right? So that is how I am having such a grouping. Okay, so here something interesting will come. See, so first let's see this, what is this term corresponds to. Now it is very easy for you, right? So the entire group corresponds to, we can see that when I am going across the column, this C retains as it is 0 0, but D is changing from 0 to 1. So I am eliminating D and I am retaining that C. So C is in 0 form, so C dash. Now when I am moving from the first row to last row, I can see that this A is changing from 0 to 1. So A is eliminated and B is like B dash, right? So C dash, B dash. So this is this term. Okay, fine. Now what else? What is the next grouping possible? See, these two ones are there, and you know, this is something interesting. These two ones, how we are going, you can group like this, right? This is one way, or you can group like this. This is another way. Can I make a somewhat bigger grouping? That is my question. So what you can do is, you can do something interesting. Just look at this color. Is it okay? this one, this one, then this one and this one. All the corner ones I am grouping together. See, when you fold it row wise and column wise, when you fold it, you can see that all these corner ones are coming nearby, right? So all the corner ones you can group together and you can form a single group out of it. Okay, so I hope it is clear. Otherwise, remember corner ones also you can group. Okay, so now I am getting a group of 4 ones. That's interesting. So now tell me what is the term corresponds to. So the first column and last column are coming nearby. So when you are moving across first column to last column, see the variable C is eliminated because it is changing from 0 to 1 and D is like a D dash. So D dash is there. Okay, fine. Now when I am going from the first row to the last row, I can see that the variable A is eliminated and B is there as it is B dash. So it is something like a B dash D dash. Okay, fine. So what is this? What else? There is a single one remains. So how can I group it? With whom I can have a pair? See, here only 2 ones can be grouped. The only thing is I just need a grouping of it. I can group like this. Can I make something bigger? That is the question. You can't, right? Because with the so I need something like 4 ones. So 4 1. It's if a 1 is here, you may be able to fold and group, but that is not there. There is no other way, right? So you have to make sure that this is the largest grouping possible. Yes, this is the largest grouping possible, and you can see that when you are going and only 2 ones are grouped means only one variable you can eliminate. So when you are going across the rows, A is 0, B is eliminated, so A dash will come, and here nothing is eliminated because just 1 0 they are fixed like a C D dash. So definitely 4 variables are there, only one variable I can eliminate, so the resulting expression will be containing 3 variables. I mean the term will be containing. So that's all. So the function will be simplified as f of A, B, C, D. So it can be written as the first term is like a let me write it B dash C dash, okay, because the ordering I am keeping B dash D dash A dash C D dash. Okay, this is fine. If you want, you can do one more level where B dash you can take outside, then this is like a C dash plus D dash, okay, A dash C D dash. Now this also by De Morgan law B dash, I am just writing B dash, this is something like a C dot D the whole dash, something like that, plus A dash C D dash. Okay, anyway these 2 steps are not needed. Up to this is enough for exam. Okay, so the first line is enough for exam. So that's simplification procedure. But when I am writing in a different way and all, I need NAND gate and other gates I needed, but this is something I can realize using the basic fundamental gate, that is AND, OR and NOT. Okay, that is enough. So see, you can see this is the solution to the first one. Hope you remember the 8 ones be grouped and they are giving some shadow for it, right? So this bigger grouping, hope you remember. And but we done other than that, these 4 ones also be grouped, right? And this one was remaining, that we grouped like this. This is what happened with the first grouping. Is it like that? Let's see. Oh, see, I got an expression containing 5 literal where those, is there any mistake? I don't know. Please cross check. Maybe some ones I may missed out in the solution given. We got a different structure, right? 4 1 1 I got 0 1 2 3 4 5 6 7 8 9, same numbering they are also following. Okay, I have to cross check it. Anyway, you can also, anyway you understood the method, right? Sometimes I may mark it differently. You can also make the same mistake in exam, so you have to be careful. Even in the textbook also there may be mistakes, so you verify what is happening. Maybe you can do yourself and you can tell me in the next class. So I got a 1 here, but it was like a 3 or 2. But in my expression why I marked a 1 there. But in the question 3 was also there, no? 2 also there. 2, sorry. In the question, see here 3 is not there, I added 3, so that is the mistake I done. See, you have to be careful. No problem, this is a different question. Okay, so this is a different question. Okay, this is how you can simplify this, that's all. Here I added 3, mistakenly I added 3, but actually in the original question 0, 1, 2, 3 was missing, so definitely answer will be different. So this is a new question. Okay, so this is not a solution to that one. The solution to that one is given here. Okay, so here we can see that there is no, so this is the correct thing. So accordingly I am having only this many grouping. Now similarly, whether I made a mistake here also, I hope no. What I done is like I taken this corner ones I grouped. Okay, this is the first grouping we did, and this one we grouped like this, same thing, but this 4 ones we grouped, I think they were not doing, but they done one more level of simplification and they written it like by grouping the corner ones we are getting that b dash c dash. Is it so? By grouping the corner ones we are getting that b dash something. Okay, anyway, both are same only. What I done is something I taken the largest group, but in the textbook and all sometimes they may first introduce you with the 2 ones and then they may proceed. This is something we can do additionally and this is a more simplified one. They may explain in that way also. Okay, that could be the reason here. If I am looking at the shade, actually this corner one, these 2 things are getting grouped, the other ones are not grouped. Okay, anyway, what I explained there is the correct way. Here in the textbook they may introduce you to that level later on. Okay, fine, that's all. Okay, that's all. This prime, implicant, essential, those things we will see in the next video. Thanks for watching.